So welcome to our closing panel. So this is going to be a panel on the standard library from the people who implement it. So we've got a number of standard library implementers here and also some members of the library working group of the C++ standardization committee. So we're going to start off by having each one of you guys introduce yourselves and also introduce one of the new library features in C++ 17. So we'll start off with STL.
Hey, I'm Stefan T. Lauwade. I'm one of the maintainers of Microsoft's STL implementation. And a couple of the features I've implemented are invoke in CS+17, which is a generic way to apply callable objects, which include not just function objects and lambdas, but also pointers to member functions and pointers to member data to arguments with a high level of metaprogramming intelligence. Another feature I implemented was the removal of features. Evil stuff like auto putter and unary function and random shuffle, and they're all gone from CS+17 because I love breaking users' code.
My name is Howard Hennett. I'm a recovering library implementer. The feature I would like to introduce is the ability to extract nodes from map and set and get non-const access to them, and you can change them and then stick them back in all without allocating or deallocating nodes. It's should be great for performance, and a lot of people have been asking for it. And it first got the idea for it first came out in 2009, so we're just about ready to put it in. It only takes 6-7 years to get something done.
Oh, and which standard library have you worked on?
I implemented libc++ for Apple, and it's now gone beyond Apple. I also did the standard lib for Code Warrior, if any of you guys remember that.
Hi, I'm Casey Carter. I work for Microsoft. I'm also an STL implementer there with STL, ironically enough. I'm also the project editor for the Ranges TS paper, so there are a couple of other STL-like libraries that I also implement. The feature I want to talk about today is standard optional, standard variant, and standard any, which are 3 different kinds of wrapper types that can be used to pass around other objects. Optional represents, either a T or the absence of a T. Variant represents one of an alternative of several different types that could all be possibly stored in the object, but only one at a time, much like a union, but smarter and safer. And any can store any kind of object inside itself, which makes it possible to type erase things and pass them through code that doesn't need to know about the type of the object being passed. However, it can be recovered safely, unlike with using a void pointer. So it's much better than our old C-style version of pure type erasure.
I'm Marshall Clow. When Howard decided he was done with libc++, he dumped it in my lap. So I am the code owner for libc++. I also am on the standards committee where I work in the library working group. I work for Qualcomm, and they're very generous in supporting all this for me, supporting my work in all of this. But I want to talk today about a couple of new features for C++ 17. The first one is what I've been calling the searchers. It's an extension to std search, where the final parameter is an object that describes the algorithm you wish to use for search. We have 3 in the standard right now, but they're fairly simple. You can write your own. The first one matches the existing behavior of std search, and the second and third implement Boyer-Moore and Boyer-Moore-Horspool search, which are really great searches if you're looking for something that has looking for a long pattern. They give very good performance. The other feature I wanted to talk about was string view. It is a what's the best way to put it? It is a non-owning const container for character-like things that are stored contiguously. Basically, internally it's a pointer and a length, but it acts as if you have a container of constant characters, and so you can use it in all the places you would use a regular container. And it's very, very nice for applications that have a lot of text processing, where instead of passing around std strings, you pass around references to chunks of text. And this avoids a lot of heap allocations, a lot of copying, and so on.
So Marshall, you said you work in the library working group. Can you tell us about what you do in the library working group?
Okay, fine. I am the chairman of the library working group. But that means I get to do all the administrative stuff, and I get to, herd the cats. Like Mr. Meow over there. So.
I'm Anthony Williams. I don't actually commit to a full part of the standard library. I've been specifically focused on my implementation of the thread library. So that's the bit where I'm a standard library implementer. The C++17 features that I think are worth introducing are where we've got variadic lock guards. So whereas previously you could have a lock guard for a single mutex, now you can have a variadic lock guard that covers multiple mutexes in one go. And you can use this to acquire multiple mutexes without having to risk deadlock. So that's a great feature. We also have shared mutex, which is new in C++17 because in C++14 we only had shared timed mutex. As a class, this just provides the implementers an opportunity to optimize, because if you don't have to support all those timeouts, then you can make your implementation simpler. And this allows, as a user feature, it's a means of saying, I've got multiple threads that are going to access this and concurrently, but they're not going to touch anything, and as opposed to just one thread on the flip side that's going to be the mutating thread. So you can have multiple shared concurrent accesses or one exclusive access. So it's great.
Thank you. Hello, my name is Walter Brown. Before I say anything further, there's someone I would like to thank, and that is my wife, who actually fabricated the tie I am wearing today. Thank you. I'll make sure she sees this part of the video. As I said, my name is Walter Brown. Until Bryce invited me to join this panel, I never knew I was a library implementer. I am retired. What that means is I get to spend 8 to 10 to 12 hours a day re-implementing pieces of the standard library that interest me and experimenting with them using the latest features of the language, of the library. I've re-implemented certain pieces 6, 7, 8, 9 times in various ways. I do a little bit of measurement. And as a WG21 participant, I try to bring that feedback to the committee, and I'm currently interested in what a future revision of the standard library might look like. We're spending a lot of time thinking about concepts influencing the standard library in the future, but there are a lot of mundane pieces of the standard library that deserve some tender, loving care, because today we can do things better than we did 20 years ago. Things like numeric limits, we can do better. So I'm thinking about things like that. The parts of C++17 that I'd like to mention specifically, one is a new addition to the type traits header. It's known as void_t. I had a little something to do with that. It is there in support of what we've come to call the detection idiom. And rather than explain that, let me perhaps refer you to the video of my talk 2 years ago, which has had, to my great surprise, 30,000 views on YouTube, plus a few thousand more on Channel 9. Thank you all. That's very flattering, considering my name isn't Bjarne or Herb. The other item that I'd like to call to your attention are some of the additions that have been made to the various numeric parts of the standard library. I'm talking about both the numeric algorithms as well as CMath itself. Not math.h, because we don't own that, but we do own CMath. And among the things that are new, for example, in CMath, we have an additional overload of the hypot function. Now we have a 3D version of that. We have a clamp function, so that the common idiom of I need a value between this and this, let's make sure it's within that range. We now have a standard way of doing that. We have GCD and LCM, greatest common divisor, least common multiple. We have a new algorithm called sample, That's in the algorithm header, of course, relies on the random number features, so that if you have a population and you want to draw a sample of a certain size, we can now do that in a portable way. And then we have something called special functions. Now, the term is actually overloaded. We think of special functions in C++ as constructors, destructors, things that the compiler could generate for you. But in mathematics, the term special functions has a very different meaning. So we refer to the special functions that are numeric in nature as mathematical or numerical special functions. We've had a lot of them for a very long time because technically things like sine, cosine, exp, these are all numeric special functions. We now have not just the high school special functions like those, we have the university level special functions, including things like Bessel and Laguerre and Legendre and beta functions and things like that. So if you do heavy-duty numerical work, you now have a portable way of incorporating that without having to write your own. Thank you.
My name is Eric Fuselier, and I work on libc++ with Marshall. I've been doing so for about 2 years, and I want to encourage any students in the audience to, if you want to get involved in any of this, feel free to approach any of us. I did 2 years ago, and it's changed everything I do. Anyway, the feature I want to talk about is file system, which we finally added in C++17. And file system is a collection of methods and classes to interact with the file system underneath you. So you have a class path, which lexically represents a path on your system. So you can do things like strip off the extension or iterate over the directories contained in the path. The other major class in there is the directory iterator and recursive directory iterator. So if you have a folder on your system and you want to iterate through all of the entries in it, either recursively or not, you can use one of those. And then the third major thing in file system is a set of free functions to allow you to query things about your file system, like if a directory is there or what its permissions are, as well as creating files and removing files and things like that.
I'll be back. He will be back. My name's Michael Wong. I'm the chair of, I work at CodePlay Software. I'm the chair of SG5 and SG14, as well as the editor of the concurrency TS. CodePlay Software supplies one of the first implementations of the parallelism technical specification that is mostly conforming as much as possible could be to C++17's version of it. There's some last minute changes. So with the parallelism TS, I would say that this is one of the features that can potentially buy you a lot of potential speedups if you just simply include it. The parallelism TS is starting us down the path of adding these amazing parallel library. I've always asked, one of the things that I asked after C++11 was, can't we finally have a parallel STL? I know STL is already there, so I wanted another, and he's so good, we wanted another version of it. So we finally have it now willed into reality, such that, and it's not just, and the thing is that with the parallelism TS, it's as simple as changing one of the arguments to any sort or any library algorithms to use parallel or vectorize. You can still get back the original one. If you don't say anything, or if you default to the sequential, which I think is called serial now. The names keeps changing, but the underlying thing is still the same.
It's seek still.
Yeah. So what happens is that with this particular addition to C++17, it opens the door to tremendous improvements as we move forward. One of the things we're looking forward to at CodePlay is the ability to support heterogeneous computing. Indeed, our implementation actually allows you to dispatch it to both the CPU and the GPU as well through the SQL language. So I'd be looking forward to talking about that. So now, back to you.
Hello, I'm Alistair Meredith. I work at Bloomberg, and I was the prior chair of the library working group, so thanks for letting me drop that in your lap, Marshall. Those of you who know the kind of things we do at Bloomberg, it'll be no surprise that the thing I'm happiest to see in C++17 is the memory resources feature, which is very similar to the allocator model we use at Bloomberg. It allows you to pick an allocator once you know more about the context of the data structure you're working with, and pick the most appropriate kind of allocator, perhaps pulling information off the stack, perhaps a pool specific to that one container, and plug that in at runtime. And we have aliases for all the standard containers that can use this new allocator, so we don't have to implement new containers. The existing allocator framework, as Herb was saying earlier, it was there already just to pick up the slack. We've just plugged in the part that we needed. And the other thing I'd like to talk about is the one that Bryce asked me to talk about last, is right at the end we reserved a new namespace, so we could now be it's a good time to start talking about, as Walter suggested, what would we want to do with a future standard library? In fact, we didn't reserve one namespace, but the committee can never really get consensus to agree on anything. We reserved everything starting with STD and then followed by a number. So we've got a whole lot of namespaces to work with, but hopefully we'll need just one.
Right, so thank you, Alistair. So why are we talking about this like future standard library? Like, we have a standard library, we incrementally improve it, but the committee recently has been talking about this idea of a new standard library. So like, what would this look like? Like, is it gonna break my code? Like, what's going on here? Why do we need this?
So let me preface this with, this is my opinion, and it should not be taken as the opinion of LWG, WG21, my employer, anybody but me. There are things in the standard library that people agree are not as good as they should be, and we wish we could change them, but we can't because it's going to break lots of people's code. There are techniques that we want to explore to see if they make for better programming paradigm, like using ranges instead of pairs of iterators. There are changes to the standard containers that I happen to think would make them much more useful. But we're not going to do that because, well, we have millions and millions and millions, to quote Carl Sagan, lines of code out there that depends on the existing behavior and the existing interfaces. And so people have been talking about what we've called STL2, which is a re-implementation of the standard library doing some of these things. And at this point, it's mostly a code name. It's not anything concrete. But a couple things. One, yeah, it will be different. Two, it's not going to replace what's there because compatibility. The Standards Committee is very serious about maintaining backwards compatibility. And so, as Alistair said, we reserve new namespaces. And so what I would expect is that you would see a new namespace called STD2 or STD3 or STD 437, I don't know which, that contains new functionality that you can use or not. And you should be able to, hopefully you'll be able to mix and match the pieces. This shouldn't be an either or choice. And again, my opinion.
Again, another reason why just after C++17, I think, could be a really good time to be looking at new library designs as much as the approach. We're getting a lot of new language features coming our way that could have a really fundamental impact as to how you would design and express a library. There's a strong chance, I'll be very upset, even more upset than Bjarne at this point maybe, if we don't get concepts next time around. We've got a runtime analog of concepts that I'm hoping will come through, which is contract programming, which is also a fundamental way of how you would describe your library interfaces. Coroutines coming into the language should fundamentally change the way we think about designing some kinds of algorithms and how we might express some of those idioms. And getting modules is going to change how we want to package up the library. So I think we're going to be looking at a fundamentally very different shape of library, even if it's got largely the same content as today. And to an extent, I'd like to drop Casey on the hook here, because I'm hoping that we've got the ranges library coming out is our first feel of using concepts to specify a library. So hopefully this could be the inception of the new standard library. That, again, personal opinion, it's my hope. But yeah, I'll pass the mic on.
So Casey, I'll put you on the spot. So tell me about ranges. What are ranges? Why should I care about ranges? How are they going to change things?
Ranges will change things by allowing us to have simpler abstractions so that we can speak at a higher level. Much like the transition from specifying what algorithms are going to operate on as pairs of iterators to using the range-based for loop, right? Everybody's familiar, hopefully, with C++11's range-based for loop. It lets me use a single object as a handle for a range instead of separate begin and end points, which makes it harder for me to make errors. And it allows me to think at a higher level of abstraction so that I don't have to be as concerned with specific details. So ranges as a tool in general should allow us to reason more efficiently in our code development.
All right, so STL, I'm going to put you in the spot now. So you talked about how you liked removing things from the standard library in 17.
The standard's too complicated, and if we make it smaller, it's less complicated.
So what things in the current standard library would you want to, like, could
IO
we
streams.
improve? Let's talk about IO streams. Go.
We should burn it to the ground with fire and then salt the earth so nothing ever grows back there. I don't know how to actually replace IO streams. I just really want somebody to propose a replacement. I mean, ranges and concepts are nice, but IO streams, it's terrible.
So maybe some of the rest of you could comment on other things that we might be able to fix or improve in a future standard library.
I've often thought that, and I've said as much, bind, I thought, was a good experiment. And it's sort of a relic of the library. Actually, here's a case where library does not do the job as well as core. We tried it with boost bind, boost lambda, library-only solutions for making small unnamed function objects. And it turns out we're bad at it, and the core language is way better than we could hope to be. And it's even better now that we got generic lambdas, you've got move captures, arbitrary init captures, and yes, sometimes bind is a little, less typing, but it's more mental work. And I think it is something that could be deprecated and removed. I currently have no plans to propose it, because all it takes is somebody saying, you'll remove bind over my dead body, and then it won't go through committee. But I would like to see it go away and have lambdas rule the world.
So if you guys have questions, now's a good time to start lining up and we'll get to
Just name something that you want to see removed, Just call it out. If you say vector, though, you'll be asked to leave.
How about vector bool?
Oh, vector bool. Okay, exception, yes.
We got Alistair down there.
Actually, any chance we could get a second mic?
Yeah, let's see if we can. Yeah.
He's right over there.
So yeah, this is another call for help. I mean, the thing I would most like to see if I had a free choice being fixed in C++17, Casey's already working on it, so I've got that one covered. The next one is in the same vein as IO streams, is text handling. C++98 came out with a standard with basic string and char traits and a lot of ways of handling different sizes of text characters. We invented the Unicode problem because Unicode wasn't a standard then. I would really like to simplify so that we had a single text handling type that had trafficked in UTF-8, and we stopped trying to have clever templates solving all character types for the whole world. I don't know how to get there, though. I have an audience of people who can hopefully step up to the plate.
There. Oh, are we?
This sort of is a question for STL. You just mentioned range-based for loops, and I stumbled across, I'm not sure if it was a white paper or something, where you described an extension to range-based for loops that were more efficient because by default, the current implementation range-based for loops can incur a copy every time you iterate through it, unless you use dereference, or an ampersand operator. Did anything go with that? Has that been something you've talked about more? Or?
Yes, we talked about it on the committee several times. Essentially, the paper said that range 4 is awesome. I love range 4. But uniquely, I think, among CS+11 features, at least in the core language, it solves a class of problems, but it actually allows for a new class of problems to be introduced silently in code that not even C89 programmers would commit. And that is accidentally making copies of elements in the range, which is bad for performance and bad for correctness. And my proposal was to introduce some kind of new syntax that would process elements in place, and that's the key. Because whenever you say deref iter, or array subscript I, or vector subscript I, you always work with your element in place, and you don't make a copy, whether you're reading or modifying the thing. I had called it range-based for the next generation. Although it was approved by the evolution working group and the core working group, it was eventually rejected by the full committee due to concerns over the syntax and potential programmer confusion involving shadowing. When an outer variable, say like named int x equals 1729, exists, and then you have a next-gen range 4 that says 4, and my syntax was open paren x colon stuff. The semantics, which I think everybody liked, was to work in place with a new reference named x. But the syntax suggested that perhaps that outer one would be used. And I said, compiler warnings. That didn't really convince the committee. And I currently have no plans to resurrect the proposal. It would need to be a different syntax, something that suggests that a new variable, a new reference is being introduced. And I have some ideas, but I just don't have time at the moment to bring forth proposals. So if you'd like to see an in-place range 4 with even terser syntax introduced, come up and talk to me. And I can give you my current idea for syntax, other ways it could be extended. Everybody asks, oh, but what about consonants? And that could be handled. So if you'd like to, go to evolution and talk about range 4 again, come talk to me.
Thank you.
And you have another question there?
Excuse me, I was wondering, this may be more of a long-term standard of how C++ will do, but as new features are introduced in STD2, will they eventually, and they're proven successful, and old features that might be kind of very confusing, maybe a little bit like STD bind, kind of are proving a little bit archaic and out of date, will there be movement in the standard library to introduce working STD2 features into the standard library and remove old STD1 features, even if it does break code?
Well, if we're afraid to make a mistake, we'll never get anything done. And I think Bjarne is very keen to make sure we don't lose sight of progress. My vision for STD2 is it is a new standard library, and we will have new idioms and things that work with it, starting with ranges as an expression, and we will have something very inspired by the existing standard library. Mostly it should be, I would hope, syntax compatible, so it's an easy migration, but I wouldn't want to see features going both ways. I would like to be making progress and getting something right. But this is very early days. We've not yet sat down as a group to figure out what we even agree the consensus for the agenda for the next standard library is. We just made a point of we're grabbing those namespaces now, so please stay out of them if you don't want us to accidentally or deliberately break your code in the medium-term future. But this is a long-term project, and these are the questions that we're going to have to deal with as we go forward.
Yeah, I just want to add to that. We don't want to be afraid of making mistakes, but part of what we're wanting to do, we're looking at STD2, is experimenting. And so I think we're going to be wanting to see several TSs coming forward. We've got the range TSs, range TS. We're going to want to see other TSs as people come up with new ideas about how to structure things, hopefully so that there won't be too much of things saying, we'd like to remove this from STD2. So when it finally becomes a core part of the C++ standard.
Michael, could I just ask you to give a brief explanation of what a TS is for the uninitiated?
So TS stands for technical specification. There was a previous term for these things. They were called technical reports. There's an ISO thing that changed the names. Basically, a TS is just a way for us to advance fairly complicated features, and in some cases, a group of features, like the library fundamental, such that they have bake-in time, that they have time for some reference implementations, hopefully more than one, maybe two. And then one of the words is always at the beginning of the TS says that this technical specification says something like this, that will be advanced into C++ in part, or in whole, or none of it, or all of it as is, which pretty much means anything can happen. Now the reality is that by and large, most TSs gets advanced into the standard, at least for the record so far, with the file system, almost 99% intact. Now, as we move forward with some of the more advanced stuff, it is conceivable that maybe only 75% of it goes in, or maybe only 50% of it goes in. With the parallelism TS, there were only 2 or 3 things that was actually changed at the very last moment. The core, the idea is still all there. The interface is pretty much still all there. So once that happens, the TS gets it's adapted in, and then we can then move on to a second TS or third TS. So these are usually the beginning of a chain of potential major features. The standard made that decision a couple of years ago where the evolution committee simply cannot contain all the major things that was happening. So as a result, they started breaking up into these study groups, and these study groups resulted in TS. So I'll add one more thing before I hand it over, because you guys are going to have more things to add that can address some of the things I missed. I'm fairly certain that there will be continuing library fundamental TSs, continuing parallelism TSs, continuing concurrency TSs, concept TSs, maybe a numeric TS, a range TS, possibly transactional memory TS. Have other things that you guys, sorry? There was an arrays, but it got killed. It got killed, but it might come back. I don't know. Module TSs, contract might be a TS, coroutine TSs. Any ones I missed? I think that barring that, that's going to be some of the things that could come in.
I'd like to comment briefly on that process. My first experience with what we now call a TS was the old TR1. Essentially, everything in TR1 ultimately made it into C++. The last bit, in fact, were those mathematical special functions I spoke about. Those originated back in about 2003 was the first proposal. So some of these things take a long time to bake, and they go through various stages. The random header is a poster child that's been pointed to by several people over the past years, because the original specification ended up in TR1, where it baked for several years. We got incredibly valuable feedback by early adopters. And as a result, what ultimately got into C++11 was immeasurably improved. Some things got dropped by the wayside, some parts of the interface were adjusted and so forth. But what we got in the end was incredibly better due to the feedback we received from early adopters, people willing to try things out and then send us comments. I mention this because I would like publicly to encourage you, once you become aware of a new TS, try it out and then tell us what you think, good, bad, or indifferent. We value your feedback, and we take it and we do our best to improve it even further en route to putting it into the main standard. So please, please, please do that. And as my own tiny little thing that I'm looking for in STD2 perhaps, we owe a great debt to Alex Stepanov. But he has publicly said for a very long time that he made one mistake, that he is eager to see corrected, and we couldn't do it because it would break certain people by way of backwards compatibility. So he would like to have min and max algorithms, right? The idea that he has come to is that if min returns one of a pair, max should return the other one, even if they compare equal. I want to see that in STD2.
All right, so did you have a follow-up or?
No, I just wanted to thank you.
All right.
You're welcome.
Okay, one other thing I would like to see in the STL2 or maybe in the current STL is being more consistent with the small buffer optimizations, or maybe even making it explicit like in Chandler's talk. Is there some plans of doing it?
Yes.
I'm sorry, I missed. Was your question about small vector optimization?
Small buffer optimizations.
Okay.
In all cases, I mean,
it has
string function.
It has to be done with a separate type. That's the key. One of std vector's guarantees is that when you swap them, it's constant time, no fail, iterator preserving. And that means that the vector object and any allocator object inside it cannot stash elements inside itself. So if you want a small vector optimization that can store stuff within the vector itself, we should not attempt to do that in a std2 vector, because that is something that's certainly not broken in vector itself. But it would certainly be reasonable to have a small underscore vector or just name it anything else, just as std_string has a small string optimization being part of a separate type, and it intentionally has weaker guarantees.
I believe there is a small vector implementation in LLVM at present. I haven't looked at it in a couple of years.
I was talking not actually about vectors, but for example, state function has a very different size of a small buffer optimization in Visual Studio and GCC, and we would like to have it somehow explicitly mentioned in the type. I don't know.
So there is so SG14, as was a library evolution group, has been reviewing a proposal called Clump. I think it's Neven Lieber, is it? And it is definitely making progress. The name's going to change because I don't think you want Clump. You want something else. You want something else, but it's coming.
Thank you.
And there's also yeah.
All right, I think over here.
Given the importance of TSs, right, as kind of a tactical strategy to deal with the amount of time between major releases, right? And also, I guess tying in with what Walter said about encouraging us to use these things. I think I'm correct. All the functionality in these new TSs is in the standard experimental namespace. Is that correct? I think.
Yes, so far.
So
yeah.
given that's the case, I think that could scare some people. I was thinking about it at lunch today. You know, convincing people the word experimental there really means the committee's just trying to announce that the API, we reserve the right to change it, right? It's just a way to reserve flexibility. But
yeah.
Do you guys consider it production ready, and is that an argument that can be made? It's effectively production ready for the next 3 years, and maybe you have to change your code 3 years later, maybe.
I think I'm going to interject. I think there's strong consensus within the committee that it is practically production ready. It's, as I said before, it's almost, in most cases, 99% of it gets airdropped in, so that we want to make sure that it's not an impediment for you to use it. You can understand why we want to put big features or large groups of features in such a context, so that so that it doesn't disturb the rest of the whole library system. But it makes it easier for you to use it. Now you can turn on GCC with a specific flag for concepts. That makes it actually easier for you to segment it out.
Well, I'm going to take the contrary position here. One of the things Herb said as convener of the WG21, the standard group, when we set out down the path of TSs, is he didn't think TSs will have succeeded until we fail to bring something forward, because it means we're not being experimental enough, we're not being ambitious enough in what we're using the TSs for. We really do want that experimental to be a hint that, yes, these things are subject to change. We're not binding to that, and we can get things wrong. If this is to lower our barrier for the things we consider to be as ambitious and reach as we can. And to an extent, we might be looking forward, if we've been a little bit conservative in putting things that are even well-known into a TS, but we're fairly confident. And we thought this was an early release vehicle. Now the standard seems to be on a 3-year release cycle. We should be much more ambitious in putting really experimental features into the TS and perhaps advancing things more rapidly into the main standard itself. But again, this will be a fun topic for us to discuss at the next few meetings.
We actually did experiment with a less scary name, and it turned out that TR1 wasn't scary enough.
Interesting, yeah. I mean, I think that's exactly the issue. You know, I'm not proposing to change the name, but it's a name that I think could people that weren't cognoscenti like us might interpret as really scary.
I think it's important to draw a distinction between the experimentalness of the interface and the experimentalness of the implementation.
I agree.
Because when you say production ready, what does that mean? Usually production ready, you would think of that talking about the implementation. And it's quite possible for an implementation to experiment with something to be absolutely production ready bulletproof, like erase if. There's no bugs in that code that we're shipping. But the interface, maybe it could change. Now that one in particular, yeah, I double dog dare you to find a bug in that. But yeah, something like Walter brought up the random header in TR1. Really, really nice in TR1, and you could have had an absolutely bulletproof implementation of that, but it turned out that the interface churns substantially to CS+11. And if we knew back then what we do now, putting in an experimental would have been a better signal to people that, hey, maybe you don't want to use stood experimental variate generator because, it's going to disappear in CS+11, which it did.
All right, let's go Arthur.
On my wish list for STL2, less operator overloading. I know IOStream is the biggest offender, but ranges with operator or and file system, I think it's operator slash. Like those are not good precedents, in my opinion.
So maybe Casey and Eric can code
You don't think slash is cute? It's cute.
The nice thing about operator overloading is it's the only way we have of using infix notation instead of prefix notation for operations. So if we want to have things that don't have huge stacks of function name, function name, function name, function name, argument, argument, parentheses, comma, argument, and we want clearer notation like a plus b plus c minus e, we have to use operator overloading. So I understand that, yes, in many cases, operator overloading is used very much wrongly, right? The more you cheat about the semantics of your operator overload versus what we call the semantics of that operator on built-in types. If the semantics are different for your overload, you're going to confuse people. We want to maintain that relationship between our intuition and how the code actually behaves so that we can reason about it and it makes it easier to read. So yes, that is somewhat of a problem in the standard library. And I think in many cases we could clean it up, but it's still going to be in the case that for some features we want to have the shorter notation that we can only get by operator overloading.
Yeah, as a concrete example of that, then one of the proposals that's currently under discussion of SG1 is an idea of pipelines. So like if you've got a Unix command line, then you can say, here's this operation, and then the pipe character, and then the second operation, and the output of the first is fed into the input of the second. Then we want to see that in source code, and then using the bar, which obviously is already an operator. And we're not going to mean OR, we're going to mean pipe, feed this into that. I think that's actually really nice and gives a very simple and visual meaning, but it's different to the built-in operator that you would get on an integer.
And it's also different to the template you would get if they happen to be ranges and so on. I just worry it takes the compiler a little while to figure that out. Humans, of course, get it instantly.
Yeah, well, compilers are getting faster all the time, so.
All right, over here on the left.
So I had a question about string view. It's been very helpful for performance, but it's implemented with a pointer and a size type, if I recall correctly.
Yes.
So my question stems from why not use an iterator pair? I've already been using a standard pair of iterators for basically string view types without using the string.
Couple reasons. The inspiration for the string view type came out of several different, disparate but related text processing initiatives, both inside the standard library and outside the standard library. And in those cases, the characters were contiguous in memory, and you do get performance wins if you're allowed to assume that. You have, just a pointer at a length is much faster than an iterator, which could be, things in a list or something like that. So that was probably the biggest reason. It's where it came from, and for needs for performance. You could certainly implement something, a view type that contained a pair of pointers. I think we're going to call that a range now, and somebody's been working on that for a while. But string view is designed to be, a specialized text processing type for contiguous chunks of text. There have been various proposals for a similar thing, slightly more general. It's called array view. I believe that Herb and Bjarne have one in the GSL, and a couple of people have proposed them for standardization. They seem to founder when you start talking about multiple dimensions of arrays. But no, I think performance and where the proposals came from are the main reasons why it's a pointer and a length.
We also do have experience with working with arbitrary pairs of iterators in the regex library, which is templated in arbitrary iterators to character type that can be as weak as bidirectional. And nobody in the entire world, except for implementers of test harnesses, have ever used regex with anything other than narrow and wide raw pointers and string iterators, sometimes modifiable iterators. As soon as you say, oh, I can work with arbitrary iterators, you're adding an extra level of complexity that nobody will really ever use. And string view just saying, I work with contiguous raw pointers to some buffer that you control and I don't control. That's a welcome simplification compared to templating it in an arbitrary iterator type.
Thank you.
Okay, let's go over here on the right.
Yeah, there has been some talk about bringing back databases into the standard library at this conference. I think one poster and one talk at least. So my question for you guys, since there was a study group on databases, is what would be your wishes for some database model?
So yes, the study group died mostly because the lead could not continue to attend. I suppose the one other thing would be we have to look at some sort of standard SQL or query language, concurrent data structures. That some of it will be coming in through other TSs. But if there's significant interest, it could be revived, and some of this could be led by you guys with a proxy at this who can attend the standard meeting regularly.
I just wanted to point out that leading a study group is a non-trivial amount of work. I mean, at the very least, you're kind of obligated to attend most of the standards meetings, which is at least 3 weeks a year. There's a bunch of work that happens between meetings. You have a bunch of people who have wildly disparate opinions on direction and how to get there, and you have to try to help everybody come to a consensus and a coherent whole. It's not a, oh yeah, I can do this, this is easy, and do it in your spare time. It's a lot of work.
But I'd like to add that there are other ways that people who are unable to attend standards meetings can nonetheless participate. And that includes, believe it or not, writing proposal papers. We have a number of successful, and a few unsuccessful, but that's to be expected, proposals written by people who are not regular attendees or who have in fact never attended, or who have now started to attend because they were successful in writing a paper or two or three. But what's important, if you're going to do that, is to find someone who can stand in for you at a meeting. It is not mandatory, but incredibly desirable to have someone there at the meeting to advocate for your paper, to be able to present the highlights, to answer technical questions, and so forth. I have done this for a number of people. The term that I like to use is locum. It's like, if a physician goes on vacation, he brings in someone else to act for him. The Latin term, I think, is locum tenens. We call it sometimes shepherding a paper. Many of us have done this for others in the past. Typically fairly successful if it's a good paper, and unsuccessful if it's not a good paper. And that's the way it should be. But if you would like to contribute, please don't let your inability to attend a meeting stand in the way of your presenting what may be a very, very good idea and a very welcome contribution to the standard. If you want to find out more about that, please talk to any of us after this is over. We'd be more than happy to answer questions.
All right, let's go back over here.
Yeah, sorry, I went again, but I thought of another question. Any possible support for quantum computing in the standard library or in the language?
No.
Maybe.
We're going to go over here.
Just very briefly, C++ has been around a long time. Languages have changed a lot. We talk briefly about the future in the opening keynote. Is there any future direction, other languages, other research areas that any of the people on the panel currently are pretty interested in perhaps pursuing or looking at how it pans out?
I think I disagree with your basic premise. Variadic templates, R-value references, lambdas, const expr. Just off the top of my head, language has changed quite a lot just in the last 5 years.
Structured bindings.
Structured bindings. What am I missing? There's more. What?
Coroutines, I think.
Well, coroutines are coming, but they're not here yet.
I'm sorry if I was unclear. I'm not saying that it hasn't changed. I'm just curious about where you'd like to go more, perhaps, if that wasn't clear.
It's probably a little difficult to answer because of how broad it is.
Well, I just say I'm very much keen to see where Michael's gone now, but he's coming back. Great, because I'm keen to see the heterogeneous computing which his guys are looking at. So getting stuff. So you write one set of source files, and at runtime, some of the work will be moved to the GPU, and the library will deal with deciding which is moving to the GPU and which gets to run on the CPU at runtime. So that as a developer, you need to make sure that it's all ready to work, but you don't need to make that decision a priori. Your code can then make the best use of the available hardware, and that's really something I'm excited to see. So I don't know if Michael now wants to expand on that. But heterogeneous computing.
Of course, it would come up when I step out. Okay, so we had a discussion in Jacksonville to the full committee about moving the existing concurrency and parallelism TS towards heterogeneous computing. And it was very well accepted. People felt that it was time, that C++ is the right place to do it. We get a lot of support from the scientific community, from the consumer community, to make that move. And I heard the last bit about trying to make it runtime capable. And yes, it is definitely one of the direction. We have the parallelism TS. We have the concurrency TS. We need executors. We need asynchronous operations. Once we get, then we have to cover data movement. How to make sure that data can be moved intelligently from CPU to GPU and synchronized. We might have to get a memory model for GPUs. Those are very complex. GPU vendors have kept that playing pretty close to their vest. We kind of know what it. The point is that we kind of know what it takes because we've built 5 to 10 fairly popular heterogeneous programming models already, and we've learned a lot from them. Some of them are very, very C++ specific. The national labs have quite a few.
There is no lack of heterogeneous and parallel programming frameworks, especially among the national labs.
Thank you. So my job as chair of SG14 is to try to collate all of these experience, and I built a few myself as CEO of OpenMP. So yeah, we're going to try to do the best job we can. So look forward to something like that. I think with a good concerted effort, we should be able to come up with something like a heterogeneous TS by the next C++.
Right. So
I just wanted to make one real quick comment on this. If you go search around YouTube, there's a talk probably from 2.5 years ago by Herb titled "The End of the Free Lunch" or "Welcome to the Jungle." I don't remember.
Free lunch is over.
The free lunch is over. It talks a lot about heterogeneous computing, but it's 2.5 years old.
During the introductions, Stefan shared his sentiment that IO streams should be burned at stake and buried. And Stefan, you're not alone. Can this group share their thoughts on the interface to replace IO streams with? Thank you.
My thoughts would be that IOStreams tries to do too much. It tries to handle localization, things like numeric formatting, monetary formatting. We've got something called moneypunked in the standard, and it's mixed in with the notion of streaming, and I think it should be separated. Things like in-memory formatting of numbers and strings should be separated from I want to write to a device, whether it be a file or an in-memory string stream or the console or whatever you have. I think IOStreams tries to do too much. It mixes too many things. And the fact You've got all of these virtuals in IOStreams that are intended to permit high levels of customization that nobody ever uses, and yet they impose a massive complexity cost and a massive performance cost. All of this should be rethought from the ground up, that we want something that's fast, that doesn't mix concerns, that doesn't mix code and formatting, so you're more friendly to localization. IOStreams falls down there. And is simpler. That would be the primary criterion, for me at least.
Okay, thanks. Over here.
One other thought that might be a comment, but maybe one of you has something interesting to say about this anyway, is another wish list for STL2 would be better, more consistent handling of customization points, such as std swap and std numeric limits, which I don't think is officially a customization point right now. And good luck doing anything that's not std visit with the name visit, I think. And you know, that would be nice.
I missed the last thing that you were talking about, but std swap, I agree with 100%.
Std visit, I believe when it comes in, it's intended for use with std variant, but it actually doesn't spin AOA, so good luck using it. National body members, take note.
All right, over here.
Hi, another string view related question. I'm sure everyone's sick of it by now, but string view does a really great job replacing a vast majority of uses of stud string, which has the obvious savings of not having to deal with extraneous allocations. But I did notice that there's sort of one operation that it seems to intentionally avoid, and that's the appending of strings. And I see a lot of code that would do something, and there's classes like this called twine and string builder in a lot of other languages, where they have references to what is essentially our string view, and then later on would iterate it and only convert it to a string at the end. I was wondering if that's something that we could potentially see come in the standard, and if you guys see benefit to doing that.
I know of at least one committee member who I have tried leaning on several times to come forward with his rope implementation for standardization, but sadly he's rather too busy leading other study groups and has not been able to come forward with that yet. So I personally would like to see that as well. It's a known area.
Okay, thank you.
I'm actually working on a std rope proposal for the next committee meeting, but it's not anything in the 17 timeframe. All right, I think we were over here.
So the standard library is getting pretty large now, and as someone who's seen plenty of green-spunned libraries over the years, it's amazing that we have three high-quality implementations that are so complete and so large. But what do you think belongs in, and what do you think doesn't necessarily belong in the library? I mean, we're seeing things, especially coming in now, that require not just detailed C++ and computer science knowledge, but also very detailed architectural knowledge, very detailed mathematical knowledge, and not all application areas use all of the standard library. So do you think there's a future for a non-monolithic standard library and what belongs in it or out of it?
Yep, Marshall.
No. What would a non-monolithic standard library look like? Certainly there's the question of we lump everything in a namespace std, which maybe we shouldn't do, and we're starting to not, thanks to Chrono, and a couple other cases. You mean like conditionally supported?
I think it would mean a different distribution strategy for different parts of the standard library. They could still be standard, but they wouldn't be delivered monolithically. And so people waiting for certain parts of it wouldn't have to wait for all of it.
I think we're actually going to get something like that when it comes to special math functions. It sure seems like there may only actually be a couple implementations of it that the three major compilers end up shipping. Because none of us really wants to write it from scratch, and we'd much rather license it.
Well, I'm of two minds here. The first one is that is pedantic. Is if you have a standard library, that kind of implies that all of the library belongs together. But that's a pedantic argument. The other thing is that I think the standard library is too small. If you look at what is available for other programming languages, there are tons of features that are part of the Python standard library, or what are commonly available with Perl or PHP and so on. And none of the stuff we have in the C++ standard library. And it's kind of annoying when you say, well, all I really want to do is open a network socket, grab some stuff, parse some HTML, and then spit out JSON. And I can do that in Python really easily. And I can't do that really easily in C++ because I have to go off and write a networking library and an HTML parsing library, and then a JSON writing library. And oh, what was it I wanted to do again? Because it's been 2 years.
Over here.
Hi, I have a question about threading support or heterogeneous computing support. We have quite a number of primitives like std-thread or std-async or parallel STL now, or executor's proposal, and the different kinds of coroutines. But to me, looks like they are not quite interoperate well. Some of them depend on some kind of magic global state, while some others depend on other global state. And what is the work in making them interoperate?
I think that one may be a little hard because it's not an SG1 panel, but I think Michael wants to give it a shot.
Right. The pieces are trying hard to come together. Executor is one of the main pieces that allows you to tie in these different constructs like async, parallel for loops, so that through these executors, you can now access execution resources, which might be a bunch of threads, a bunch of GPU cores, or something else. The other part of your question about state is interesting. And indeed, this was something that we had to deal with quite a lot through SG1. Some of the parallelism TS actually had started in the TS as state, such as the dynamic execution policies. That was one of the things that was removed because we did not want to maintain state. Okay, that happened at the very last minute because we just don't know what execution policies would look like in the future. Additionally, so yes, I can't argue with what you're saying. The committee is aware of some of these things that are happening. We don't have so. Yes, some of this is just very much work in progress. But we are trying to make sure that what we have will work towards what we think we're going towards the future.
So we're running a little low on time, so I think we're going to have to go for brevity. We can probably finish the questions we have in the queue, but no other ones. So let's go on the right over here.
So Marshall, I really like what you said about other programming languages. I'd like to follow up with a more generic question about that. So how much do you guys look for how other languages do the simple things? Because C++ is very good at complicated stuff. That's why we all use it. That other languages don't do, right? But for example, I deal with a lot of people who learn C++ in my job, and they are really surprised if they come from another programming language that for simple things like, take a string, search and replace a certain substring, like all occurrences of that, which you can write in one line in most other programming languages, and you can't do that in C++. And many simple things, as far as I know. Many simple things like that. And they're really surprised by that. So my question is, how much do you look for simple things that other languages do that are much more complex in C++, and how you could improve this for future versions of the standard library?
I'm going to let one of you guys respond to that briefly.
Can we do 5-word answers?
Yes, I think that's
5 words
a good
only.
direction.
It's a challenge for us.
That was 5 words right there. I'm going to try a little harder than that. I don't spend my recreational time going out and programming things in other languages, but I do look at them and I think about that kind of thing, especially when I'm designing new bits. But it's not at the top of my list of priorities. It's a concern, but not the most important concern.
Okay, over here.
Okay, quick question, cryptography in STL. Do you think we should see cryptographic functions, and is it a priority?
Yes, we will.
Okay.
Over here.
Hi, I absolutely adore C++ for the ability to create your domain-specific languages. Yeah, things like cons, exp, if, contracts help a lot. But the question is it reasonable to expect in the future a more direct support for creating your own domain-specific languages?
So I think we're going to skip over that one because that's not so much a library question, unless we have somebody who wants to give a very brief answer.
No, that's not library.
Okay. Sorry. Over here on the left.
So I wanted to ask, where did it come from, and how do you feel about the tendency to be producing low-level library features which can only be implemented by compiler intrinsics, as opposed to putting them in the language, I guess? Std address of, for example.
I'll answer if nobody else does. But
Well, I want to say, as somebody who doesn't work with a compiler team, I really, really dislike library features that require compiler support. But sometimes you need it. And so I would, it's a matter of working out whether you really, really need it or whether it just makes your life a little bit easier. And for those cases where it just makes your life easier, well, the library that ships with the compiler can use compiler-specific intrinsic, but we need to work out whether it's really required.
Your example, address of, until very recently, it did not require compiler support. Until we slapped constexpr on it.
Over here?
Sorry.
Will there be better support for no exceptions being thrown in the next standard library?
That's a great question. How about having the new version of new be no except?
SG14 is working on exception light.
Them's fighting words.
Just working on it.
We could have a whole panel on that. I think it'll be an interesting conversation within the committee.
How do you feel about terminate?
Okay, over here.
I actually just had a quick follow-up on my previous question. I kind of agreed on Wednesday to produce a paper that is going to be a library feature that requires intrinsics. Would I be better off trying that as a language feature and letting that get pushed back to library facing, or would it be better off taking the library approach first?
We have a fair number of library features that require intrinsics, type traits being a good collection of them. It's kind of a mix between things that can be done library only and things that must be done in the compiler and can optionally be done in the compiler. In general, I would say that you should design the feature in the simplest way possible, and if that means making it a core language feature would simplify it, that's what should be done. If the interface looks like a library and it just happens to require some compiler support, I wouldn't be afraid of specifying as library. We know, with apologies to Anthony, we know how to work with compiler vendors to get hooks. I think one of the things that actually held back TR1 is that it tried to specify type traits such that they were allowed to be implemented with a purely library only, and we experienced such an increase in power when CS Plus OX became 11, and they were required to produce correct answers all the time. So I think trying to avoid compiler intrinsics may actually do damage to whatever your feature is.
I just want to point out that we have had papers come in, not just once, but several times, where the author described what he was trying to accomplish and has outlined two approaches. One that requires compiler support, one that is a language change, for example.
Last question from David over here.
So now in the standard we have error codes, and we have exceptions, and we have the file system library, and like new proposals like the 2D graphics library, which have two function signatures for every function, one that throws an exception and one that returns an error code. Is there any hope for having a consistent error handling story for C++ in the future?
Yes, there's hope. No, I don't know what it will look like.
I mean, I would say what you're seeing in the library right now is our attempt to be consistent. File system is the pioneer of a new approach that provides both in case you want to locally handle things. We can't do any better without core language support. Like, what do you want? Like, error codes or exceptions? If you want both, then we can't unify them without core help.
Okay, let's give our panel a round of applause. Thank you, guys.